Welcome back to another episode of Measurement in a Minute. I'm your host, 𝗦𝗧𝗔𝗬𝗓 with Lakeside Process Controls. And in today's episode, we're continuing our discussions around Rosemount's 3408 non-contacting radar level transmitter. In the past few episodes, we've talked about the evolution of radar technology, the differences between pulsed and FMCW technology, and why non-contacting radars reign supreme over ultrasonic level transmitters. Today we're going to talk about frequency selection within FMCW radar. So there's some decisions to make, and it's not exactly straightforward, and there's not one choice for everything. So I wanted to get into some of the nuances behind frequency selection. So in general, we have three frequency ranges to pick from. First up is low frequency. Now, low frequency is something that is very good at penetrating condensation, vapors, dust, things like that within a vessel. And low frequency is what we quite often use on these big, large inventory vessels. And I want you to think of an analogy when it comes to low frequency radars. And it would be, again, similar to sound. When we are driving up to an intersection and somebody's blasting music in the car beside us, and let's say we have our windows up, they have their windows up, what do you hear coming through their car, right? Do you hear the high frequency sounds? No, you hear that low frequency bass, those thuds coming through their car into your car. The same principles apply here. The low frequency radars can penetrate through a lot of stuff that is in that vessel. The trade-off is that it's going to generate a wider beam width. Okay, next up we have what we call mid-frequency radar, and previous generations this was actually considered a high-frequency radar. There was nothing above this, so this has been rebranded as a mid-frequency radar. And then last but not least is a high-frequency radar, closer to 80 gigahertz. Okay, now the flip side in a high-frequency radar is it's going to have a much narrower beam width in general. It does depend on the process connection you're using, so it's not always going to be a smaller beam width, but in general it is. And it can be squeezed down into smaller process connections. The trade-off is it's not going to be as good at handling vapors and condensation, as well as turbulence in the vessel. And so that's really where we have this mid-frequency. In the middle here is kind of this Goldilocks sweet spot between the two. And like I said, it's not that straightforward as to when to use one versus another, but hopefully now you're aware that there are three to pick from, and we have different technologies and different solutions for each depending on the applications that you utilize them for. Low frequency in general we see as being very good in large tank farms, terminals. These applications have a lot of vapors, but they're also much bigger vessels, so wider beam width isn't as big of a deal. Mid-frequency radars are going to be used in a large variety of applications. So anything from smaller tank farms, solids applications, things with agitator blades, high turbulence. And then high-frequency radars are great in vessels that are really small, small connections, a lot of food and beverage, life science, water, wastewater industries works really well here. In general though, we try to stick more with the mid-frequency radar in some of the tougher applications, just given the inability for a high-frequency radar to deal with some of these additional challenges. And we'll get more into this in the next few episodes. Should you have any questions about Rosemount's non-contacting radars or any other of our products, please reach out to us using the QR code on screen. Thanks everybody. Have a great day.